It's my very great pleasure, first of all, to introduce Dr. Joe Conaghan, because both of the boys that you can see, Steve Davies and Joe Conaghan, and of course Giles Palmer, who's with I3, I trained all of them at Hammersmith Hospital. But particularly for Joe, who's really one of my favourite embryologists, he was one of my first embryologists. And I just always knew he was going to be a top embryologist, destined to go far, which of course he did. And he went on, first of all, to get, after his training as an embryologist, he went on to get a PhD in human embryology from the Royal Postgraduate Medical School in 1994. He's a board-certified high complexity clinical laboratory director, that's a mouthful, in the disciplines of embryology and andrology. He has directed numerous facilities in the US, including the University of California, San Francisco IVF program and the Pacific Fertility Center in San Francisco. He's a faculty lecturer in reproductive technology at San Francisco State University and is a dedicated mentor and teacher to the next generation of embryologists and IVF laboratory directors. I'm going to actually hand you over to Joe so that he's going to introduce the meeting. Thanks, Joe.
Thank you, Karin, for that kind introduction. I still remember the day back in March 1988 when I first met you. I came for my interview at the Hammersmith, and back then things I think were done a little differently. After you had 6 people to interview. It was you and Nikki Winston and Robert Winston who were the interview panel, and all 6 people who were interviewed, you asked them to stay behind. And then at the end of all 6 interviews, Professor Winston came out and he pointed to me and he said, "You got the job." And then they brought the people who didn't get the job, the other 5 people that were there, they brought them back into the room and they talked to them about their interview skills and about the reasons why they didn't get the job. It was so beautiful. And I think that's kind of lost now. We don't do that anymore. So it was a great honor to be at the Hammersmith, obviously.
You were very special. And I remember you from you'd worked on the fish factory in your summer holidays, hadn't you? I remember that well.
Yeah, we won't talk about that. But yeah, so anyway, we are here today. It's 80's famous. I started in 1988. Karin, I think you started in 1982.
Yeah.
Steve came behind me. So, you know, we are, you know, I don't know, Michael J. Fox was the person who came up with the, he was asked in an interview about being famous, and he pointed out, he said, he overheard someone saying that Michael J. Fox was 80's famous, not just famous, but 80's famous. So something special about the 80's. And for all of you on the call, you know, think about it. Can you remember your favorite 80's band? Bon Jovi, REM, ZZ Top, or your favorite 80's movie? My favorite 80's movie is Ferris Bueller's Day Off. So, you know, here we are, 80's famous, right? So we all have mentors, and Karin was a great mentor to me. I try to mentor people. Steve also, I know, has been a great mentor to many people. And, you know, we're going to talk to you today about some of the stuff that we did back in the 1980's and the sort of science behind it, and what it's going to be a glimpse of what IVF was like back in the day. So I worked with Karin, as I said. Nikki Winston, who's the lab director at the University of Illinois in Chicago, couldn't be with us today, but I hope maybe she's in listening. And then Steve Davies came and joined the team, and then Susie came after you, Steve, I think. So there was like that sort of original core group of embryologists. And you know, hopefully all the people in the room today are going to get to see some interesting stuff about what happened. Steve, I will introduce now. Steve trained as a biochemist and subsequently completed a PhD on oocyte maturation in mice back in the day. And in 1991, he co-founded Embryogenesis, which is a huge IVF clinic in Athens, Greece. And for 30 years, Embryogenesis was one of the largest and most successful centers over there. And that's credit to you, Steve, and the good grounding that you got when you were training at Hammersmith Hospital. Embryogenesis also had the first pregnancy in Greece after PGTM for beta thalassemia, first pregnancy with ICSI, TESI, first clinic to open in-house PGTA. So Steve, you've achieved a lot over there in your time. You introduced FISH, then ArrayCGH, then NGS, Introduction of time-lapse imaging in Greece in 2011. You were really on the cutting edge back then. And you've also won an award for one of your presentations that you did at ESHRE back in 2012. Steve is an ESHRE certified clinical embryologist, great guy, always the guy to sort of stick his finger in your ribs and question you and say, why are we doing it this way? You know, always challenging, always asking those great questions. So over to you, Steve.
Thanks for the introduction, Joe. I mean, it's the years we spent together there were amazing, and I think set the ground for all of us. But you know, Karin was responsible for this amazing unit at the Hammersmith. You know, she's so well organized and so pedantic about the details that she set up a lab which allowed no mistakes. You know, we used techniques which other people weren't using. We had safety levels for even on basic level that, you know, other teams weren't using, and it allowed us to take a massive step up. And it's all thanks to Karin for the setup in the lab and what we learned and how we started. So this organization that, you know, Karin has taken her through, I think, all her professional career. You know, when we started, she was virtually non-existent in the lab. She was out in the office and just controlling everything. We were like the puppets inside. But her organization was, you know, fundamental to the success of Hammersmith at the lab level. So thanks, Karin. So she started working in 1982 there, and when we joined, it was fully developed and a good, stable environment. She then went to make on significant contributions in training embryologists on laboratory processes and regulations. She was found a member of the Association of Clinical Embryologists, ACE, which was set up in 1992, which she chaired for 10 years. And this organization set up training schemes for embryologists. This was probably one of the most important eras in the UK, where the embryologists suddenly were taken out of being the, you know, the Wild West in the lab and actually needing some training procedures and control. And Karin was the person to do this. You know, she set up the first examinations for embryologists in line with other clinical scientists in the UK. She also sat on committees for the Human Fertilization Embryology Authority, the HFEA, which became, after the interim license authority, the overall authority for reproductive biology in the UK. She was also the first embryologist to be appointed by the Department of Health and was inspector for the HFEA and the Registration Council of Scientists. She has substantial experience of quality management systems and is latterly working in the NHS in quality governance. You know, she's taken this all through her life. She's very good at organizing people and very good at making sure, you know, they work to the letter. And this was our training, and I think this is why Joe and myself and Giles were able to set up other clinics and work and make a success from the beginning. You know, it was based on Karin's training that we were allowed to do this. So thank you, Karin. And I pass over to Karin now to introduce.
Thank you to both
Joe.
of you. I don't really recognize myself in the things that you said, but I mean, we did some amazing work together, and it was so hard in those early days. We had such a fight on our hands because it was all run by the clinical directors at the time, and embryologists had very little standing, and yet the work that we did was just so important, because if we did not get that laboratory work right, if we didn't get the fine detail, we will go on to talk about culture media. You know, if you were out by the tiniest incident, a little gram, then you could affect everything that you did. It really was pioneering work in those days. And as you said, there were no training schemes, no accreditation. It was also times when we could try new things. It was not regulated at all. And whereas nowadays, it would be very difficult to change anything. It's all so regulated. In those days, I guess you could almost say we had fun. We were very entrepreneurial, and you know, we spent a lot of time trying different things, changing things slowly and carefully. And as Steve said, I did work in the labs. I could assure you, I did keep up my competence in the labs, but it was a hard fight. It was a hard fight to get everything through, and the regulations through, all the laboratory procedures, all the ICSI training, everything that we introduced. And I am quite proud, really, to have been there at the beginning and be part of that. But you guys are, you know, you've really taken the batons, and as all the other participants here, and made this a great IVF world. So after saying that, I'd like to introduce our first speaker, who's Dr. Kimball Pomeroy, sorry. He's Chief Science Officer at Ivy Fertility and oversees multiple US IVF labs. He's an expert in various areas, including COVID-19's impact on IVF labs, best practices for nitrogen tanks, cross-contamination risks in liquid nitrogen storage, embryo morphology's predictive value for pregnancy, and microbial contamination sources during embryo culture. With a master's from Bristol, UK, and with a PhD in animal physiology, he's worked on the Human Genome Project. Dr. Pomeroy has extensive experience as a human embryologist and consultant globally, focusing on cryotank failures and oocyte pH regulation. Kimball will talk about just what goes into culture media and the way we were, which will be very interesting. So over to you, Kimball.
Thanks so much, Karin. And thanks for the invitation to talk with people here. You know, I hope that I'm going to be able to at least express some of the unique things that we learned during the beginning periods of doing IVF, and especially media formulation. I remember someone once asked me, they said, what was it like doing IVF in the beginning of my career? And I replied, well, we had very few regulations. There's no CAP, CLIA, or FDA. We didn't do ICSI, we didn't do biopsies, and we didn't have big legal problems. We just mixed sperm and eggs together. But I remember I thought about that a little bit more, and I thought we did a lot more than that. In many ways, those olden cycles were pretty complex. There was a lot that we had to do. So I've been asked to present a brief synopsis of what we used to do and how we got to where we are today. This is a fairly North American view. I'm sorry, but that's the only perception that I really have, other than my initial training in Bristol, England, which I'm very grateful to the team of the late, I'm trying to remember his name, Dr. Hull. And there are people there that really worked to train me. I'm going to talk a little bit about what it was like in the olden days and a little bit about the history of media, and end up asking a question that Karin alluded to, and that was, how do we advance in this field without human experimentation? I mean, it's easy to forget that our field of clinical IVF developed under thick clouds of moral indignity. It was a rough time. Objections ranged from human experimentation to playing God and to manufacturing life. It was considered unethical not only by a lot of the lay people out there, but even by some of the colleagues of the pioneering scientists. Steptoe, Edwards, and Purdy had to combat a lot of bad press. Our predecessors in this industry not only had to practice medicine and be great scientists, they had to deal constantly with ethical issues and defend their views on IVF. Now, here's a picture of these mavericks: Bob Edwards, Gene Purdy, Patrick Steptoe. They were heavily criticized for using the public forum. They reached out to the media. The Ford Foundation pulled out the funding to Edward's salary due to the controversy over the ethics of doing IVF. MRC, the Medical Research Council of the UK, did not approve further funding in 1971, so they had to find private funding. And the biggest objections to the work they were doing was, why not do this in primates first? It had already been done in rabbits in 1959, hamsters in 1963, and there were mouse live births in 1968 via IVF. But in 1972, these mavericks decided to skip primates and go straight to humans. In the United States, Howard and Georgiana Jones were often criticized by their colleagues as they proactively fought the fight against being deemed unethical. They were accused of proceeding, and I quote, proceeding Russian-like in their operating theaters. We may view these people as heroes, but how would we be viewing them if the first babies had large offspring syndrome or were affected with severe defects? I think one of the unknown heroes of IVF is Dr. Subhas Mukherjee, and he suffered so much criticism and pressure from producing the first IVF baby in Asia and was harassed so much by the West Bengal and Indian governments that he eventually ended his life. We cannot imagine the negative press that our predecessors had to fight in a public forum. Now, almost 40 years later, IVF is routine and millions of babies have been born through its practice. There are still many ethical issues in our field. To mention a few, what do you do about surplus embryos? What about pronuclear transfer or three-parent babies, or cloning, cytoplasmic transfer, sex selection, and the production of transgenics are just a few examples of controversies that continue in our field today. And here's a couple of other controversies. This is Dr. Jeffrey Steinberg, and he was criticized when he advertised that you could now choose the eye color of your baby. Is this the beginning of eugenics? And will we be soon selecting for basketball or ballet eggs? Another controversy has been John Zhang's work outside of this country, where he delivered three-parent babies, where three individuals contribute to this embryo: sperm DNA, ova DNA, and mitochondrial DNA. How many remember the big ethical discussions that were initiated in 1993 when Dr. J. Hall announced human cloning through embryo splitting? The uproar was probably more over the use of the term cloning. I was then a student at Colorado State University with Dr. George Seidel, and we had been doing the same thing in cattle for many years. We took an embryo with an implantation rate of about 50%, and we split it with a crude razor blade, and we produced two embryos, and each of these demi-embryos had an implantation rate of 40%. A statement by the ethics committee of ASRM at that time stated, since embryo splitting has the potential to improve the efficacy of IVF treatments for infertility, research to investigate the technique is ethically acceptable. I don't know if that would fly in today's situation. I put forth that it hasn't been practiced, this embryo splitting since then, due to the unsavory term cloning. Splitting may have been a better term. Our predecessors had to be fighters. They fought against public opinion. They fought against controversy. In the beginning, our ignorance was our worst enemy. We didn't know where the toxins were or how to remove them. Heck, we didn't even know what toxins we had to try to remove and at what concentrations. I doubt whether we even know a lot more today regarding toxins that affect embryos. But let's not forget the errors we made in developing tests to determine who is fertile and who is infertile. In trying to measure fertility, we use tools that aren't around anymore or are seldom used, like the postcoital test, the sperm mucus interaction test, the sperm survival test, the zona-free hamster ova assay, the MAR test, and of course, one that's still around, the semen analysis. Where have these tests gone? And we need to investigate, why aren't they used anymore so that we don't bring forth more tests that are not very useful? The purpose of these tests was to help us identify infertile couples or to identify appropriate treatments for specific impairments. Our research showed that these tests correlated with infertility, but correlation is not enough. We have most of these tests. Why have most of these tests disappeared? Often we implemented these tests without knowing the strength of the correlation and without measuring the test specificity and sensitivity, its false positive or false negative rate. For example, let's say we propose a hyaluronan binding assay to determine if a sperm specimen will provide normal fertilization versus low or failed fertilization. Well, we must first determine if the hyaluronan binding assay results correlate with fertilization rates. And then we have to know something about the ideal cutoff value of binding that separates good fertilization from poor fertilization. The best tool to determine it is this tool here, the ROC curve. Here is an idealized ROC curve where one plots the true positive rate against the false positive rate. The true positive rate is the test sensitivity, and the false positive rate, which is really 1 minus specificity, is plotted down here. As the curve moves from this diagonal, the random classifier moves further out, it becomes more useful and helps us to better separate whatever the two disease and non-disease states are, say fertilization and failed fertilization. In addition, the curve can predict a useful cutoff point. We spend a lot of time performing tests whose usefulness was questionable. We use these tests prior to knowing a lot about their sensitivity or specificity. Often all we knew was there was a correlation. Many of these tests were used without our knowledge of how accurate they were in predicting diseases. And once we started using them, we found that their value was not very high. The sensitivity and specificity of a test to its clinical correlate is one of the most important things to understand in deciding whether a test is useful. What did we learn from PGS when we were doing fish? Are we sure we're not making these same mistakes with PGTA? I remember when I began IVF in 1990, we were at the end of using a laparoscope to retrieve eggs. We were starting to use ultrasound, and this made ovarian retrievals during this time and the time prior a technique that was practiced in the operating room. We also did GIFT, which was also heavily practiced and involved work in a surgical suite. I think it's surprising that we had 20% pregnancy rates with IVF and maybe about 50% with GIFT when we did not even know what was in the air of these surgical suites. We had no idea if there were volatile chemicals from formaldehyde, alcohol, or some strange cleaning detergent. The best we had was a HEPA filter, brooms, and mops. Lots of us have worked in these OR suites. Fortunately for most of us, we now work in dedicated IVF surgical suites and laboratories, and we can better control the exposure of embryos to potential toxins. Today's embryos mainly are exposed to just bottled gas, but is that much different? Today, do we know what is in our bottled gases? Why is there no research into something so critical? We will spend millions to have low volatiles in our laboratories with expensive air systems, while we may be pumping toxic volatiles into our benchtop incubators via bottled gas. The solutions and tools we used for IVF were often poorly characterized and were not made for human use. They were appropriated from the Sigma chemical catalog or maybe a hardware store. And if we couldn't find the right tool, we would MacGyver it in the lab with maybe duct tape and paper clips and rubber bands or cut off ends of pipette tips. I remember Lucinda Viek telling me that when she was at the Jones Institute and was beginning to do work in IVF in the United States, that she ordered dishes for culturing ova and embryos, and when she got them, she received the wrong type of dish. She received what we now call organ well culture dishes. So she decided they might work. So that accidental mistake is how we came to use organ well culture dishes. We bought our oil, if you remember, at the pharmacy. squid mineral oil with no paperwork indicating its formula or if it had been quality tested. Water usually came from laboratory stills or from a millipore filtration system. Those not so lucky to be in laboratory with stills or filtration systems used water from chemical companies, often water for HPLC. I remember a clinic in Australia that used distilled water to make up their own media, only to find out that their water was contaminated with a volatile toxin, an embryo toxin, that co-distilled with water. And so their water, depending on the time of year, was contaminated due to its source, and it could not be removed via distillation. Hopefully, we learned a lot from these past mistakes. Some of our biggest challenges in the beginning were dealing with media formulations and protein supplementation. I just remember there were many different media formulations that Steptoe, Edwards, and Purdy used as they were developing the IVF technique in humans. I only have time to mention a few issues with media, so I'm going to start with some of them here, but I should mention that there's a great review. One of the best that I've read is by Chronopoulos and Harper in Human Reproduction in 2014. And I highly recommend that if you really want to understand the issue of media development in IVF. The first culture media was based on the composition of human serum. That was Ringer's media. And this was the starting point for most of the culture media today. Now I've got a question for you IVF history buffs. What was the culture media used by Steptoe and Edwards for the first IVF media? You can ring in now. It was Earl's simple salt solution. It was supplemented with pyruvate and the patient's serum. Now, prior to that, there were other media that were used, but this is the one that was used for the first human birth. Later, Steptoe and Edwards used Ham's F10 with fetal calf serum or with bovine serum albumin. B2 media was developed by Menezo, and it was later modified for human usage. Turbid et al. Developed synthetic oviduct fluid for sheep, SOF, and this was based on the composition of the sheep oviduct, which was modified later by Patrick Quinn to more closely match the composition of the environment in the human fallopian tube. There were many other scientists that contributed to our knowledge of tissue and human culture media. And here's a comparison of many of these different types of media: EBSS, HTF, KSOM, all of these up here. Some of these scientists were John Biggers, who did a lot of work, and a lot of his students. He observed that mouse embryos that didn't develop well in culture developed to the blastocyst stage if he placed mouse oviducts into tissue culture with them. This led to the development of co-culture techniques, which was pioneered for humans by Klaus Wiemer and others. Klaus used bovine fibroblasts that were cultured with human embryos in a dish for several days. I remember one time talking to Klaus about him harvesting his cells, and he told me how he would travel to Canada to harvest his bovine cells for IVF. And at the same time, he'd make a nice skiing trip. The first media I used for IVF, I think, was Ham's F10, which had these packets of pre-measured powder that you mix together, and you had to add bicarbonate and glutamine and water into a large 1-liter glass cylinder. Then they were mixed, and after that, they were sterile filtered, a dry filtration technique, into one of these large roller flasks. After mixing, the solution's pH had to be adjusted by adding sodium hydroxide or hydrochloric acid. Then it had to be filtered and sterilized, as I mentioned. And usually there wasn't big sterility testing and just a small amount of QC testing. Many of us would make up 2 batches of media and then split the first eggs we had in our cycles until we had some sort of gut idea of which batch was the best. And we would use that batch until it expired. There were several protein supplementations that were used, but one of the first was the patient's own serum. This was obtained by venipuncture from each patient. Then it was allowed to clot until the serum could be centrifuged off. Then the serum was heat inactivated in a water bath at 56 degrees centigrade to remove the activity of complement, and it was filter sterilized. We prepared adequate amount of serum for each patient so that they would use their own serum for their own embryos. This was greatly simplified and was a blessing when commercial protein sources began to be used, especially albumin and serum substitute, SSS. In those times, it took a lot of nerve to be an innovator and try out a new formulation on your patient. One of the biggest innovations was the introduction of new culture media for human embryos instead of using culture media for either tissue or other species. Embryologists like Brinster, Patrick Quinn, Menezes, Bavister, Whittingham, Biggers, Witten, Gardner, and many others worked to hone media for culturing of human, mouse, and livestock embryos. At first, simple media and the complex media, also like HAMS-F10 for tissue culture of cell line, they were used. But the researchers above measured the constituents of tubal fluid of various species and developed simple media based on these observations. As mentioned previously, turbot for sheep. Then there was Menezes for cattle, Quinn for humans, and Gardner for mice. And these became our first commercial media. It made our lives much simpler. We did not have to make a lot of media, do quality control testing, and worry about the quality of that media. Here's a chart comparing the constituents of these media types. You'll see they're highly variable. It's amazing that the embryo, the human embryo especially, is so plastic that it can grow in this wide variety. Here's one that I know you're not going to be able to see that, but I want to show you the formulation for HAMS-F10. Those other media had maybe 10 constituents. Here's HAMS-F10 with almost 50 constituents to its formulation, a very difficult media. We also used to purchase large quantities of Pasteur pipettes, and we'd use these for moving eggs and embryos. We would fastidiously wash and rinse these pipettes, often rinsing them up to 10 to 40 times with distilled water to remove any traces of detergents. They were then placed into metal cans and sterilized by heat. To use these Pasteur pipettes, we often had to light a Bunsen burner, as is shown here, and then pull the pipette to a smaller size. You had to develop the skill to make sure you could quickly pull the size of pipette that you needed, and this became very important when you're doing stripping of the cumulus cells. I think most of us, after learning this, could have been hired by Disneyland as glass blowers to make dolphins and fairies. Now, how glad we were when someone observed that plastic pipettes used to load agarose or polyacrylamide gels in molecular biology for electrophoresis were the perfect size for human ova and embryo. Almost all of our supplies were borrowed from other industries in science and from other species, even our incubators. I remember the initial incubators that we had were large boxes that used a tank of CO2 and would mix it with room air using an aquarium pump. I'd like to close by bringing up one of the large ethical problems we face in much of medicine. Remember, the big initial opposition to IVF and many other new technologies was and are that they are unethical because we are experimenting on humans. James Watson, one of the discoverers of DNA, I'm sorry, let me go back here. I guess that got covered. Anyway, James Watson, one of the discoverers of DNA, publicly told a congressional hearing in 1974 that with successful IVF, all hell will break loose politically and morally all over the world. Well, maybe he was correct, but I don't think the cause of that has been proven. I don't think it was the human IVF. A question we must ask ourselves is, can true advancements in human reproduction be made without experimentation on humans? There are those that claim add-ons like hatching and PGTA are just that, experimentation on humans without proven benefit. The patients then are actually part of in funding this experiment. There are others in our field who feel we have become stagnated by not making any true large advancements. Gabor Vata, in his book about oocytes and embryos, which I should recommend, is a very entertaining read and very inexpensive, said industrialization and commercialization of IVF also seem to stifle creativity, and rigid in-house protocols and rules may further restrict innovative thinking. Experimentation on humans is a necessity for any improvement in medicine. What probably matters more, though, is how this research is approached. How are the known and potential risks relayed to participants of a study? And is the inducement of one of these patients to a study similar to the offering of water to a thirsty person in the desert? We can learn about some of these risks by using animal models in research, but eventually the human must be the guinea pig. In a field that is so difficult to perform research in, there must be some happy medium between stagnation and advancement. I salute those warriors of the past that fought to advance treatment of infertility and that has benefited so many couples, and I thank you for your attention. Back
Okay,
to you,
thanks,
Joe.
Kim. Yeah, thanks, Kim. Very interesting. You know, obviously this is a subject that we could talk about for days, and you did a very nice job in sort of covering as much as you could in a very short period of time. Quick question for you. You mentioned a lot of big names in your talk. Who do you think was your greatest mentor and why?
Well, I wish I could have said John Biggers, because I think he's one of the greatest, but I never got to work with him. You know, I would probably say it had to be the people that I worked directly with cattle. George Seidel, Dick Bowen. These were people, and then there was a guy named Frank Kuzan that probably most people don't know that used to work at, I think it was University of Washington. And he taught me everything in the beginning having to do with how to make media. And then I had to go to Tom Turner whenever I had any questions. He and Lucinda Veek were my peers that really spent time helping me figure out how to do things correctly.
And you know, the philosophy back then was always like, see one, do one, teach one. I mean, you know, they didn't spend a lot of time, you know, holding your hand and getting you up to speed or something. They had showed you, said, off you go.
Right. There was almost no passing it off. I remember I had someone from RBA in Atlanta come by, and I watched them do about 5 ICSIs. And then they watched me do 1 ICSI, and I was passed off.
Mm-hmm. Well, Kim, thank you very much for a great talk. I mean, you really emphasized the fact that we all stand on the shoulders of those who have gone before us. And I hope that we will keep that going within our industry as time goes forward. So we need to move along, and I am now going to introduce our second speaker. Our session today is actually being sponsored by Cryos International. And Corey Burke, who's our second speaker, works for Cryos, and he has over 30 years of experience in the reproductive industry. He is the tissue bank director at Cryos International, and he's been there since 2014. And he spearheaded the establishment of their egg bank program, which is based in Orlando. And he ensures safety, quality, and scientific advancement of the labs and global egg banking operations within the company. He strives to offer diverse and extensively screened donor sperm and donor eggs to assist families worldwide in advancing successful pregnancies. So I would like now to hand it over to Corey Burke, who's going to be speaking to us about sperm freezing, sperm banking then and now.
Well, thank you. Let me get this where we need it to be. Okay, so first off, I have to say that I am not an 80s guy. I've been around since the 90s pretty much, but I'm not as old as Kim, so I have to say that to start with. To start talking about this, I think one thing I have to do is go back a little bit in time and tell a little bit about the history of sperm banking, because we can't really talk about sperm banking until we know a little bit of the history. So Giles told me we want to talk about the 80s famous. Well, that's kind of the beginning for sperm donation, because the first successful sperm donation was in 1884, so about 100 years prior to what we really want to talk about. But Dr. William Pancoast chloroformed the wife of the recipient with the husband's permission, of course, so it was all okay. There was no harm, no foul there. He gave the okay. The best-looking medical student provided the specimen. They used a syringe, and they injected the wife. She became pregnant. She was never told how she became pregnant, just that she got pregnant somehow. This was revealed later in a medical journal in 1909, describing how the process went. And, you know, this was kind of a dubious beginning for sperm donation, but sperm donation considered or continued in the same fashion for decades to come. The first pregnancy using a frozen sperm donor was in 1953, and that's something that you have to have a sperm bank. You can't really sell fresh sperm from a bank. It just wouldn't last that long. You'd have to have a huge number of recipients and donors to make that work out. So that's why we're not talking about egg donation in this particular segment, because obviously we're not freezing eggs very well if we were freezing them all in the 80s. But anyway, that's the first step to sperm banking. You have to have frozen specimens that work. 1953 was when we came about that. You know, all the inseminations prior to that with donor stuff was very private. We don't know a lot about them. People didn't talk about it much. I mean, there's certainly some history that you can find, but mostly they were matters only known to the doctor and the recipients and perhaps the donor. In 1954, and this kind of goes back to what Kim was saying earlier, you know, there was a lot of fallout, ethical debates, legal debates, religious debates. And in 1954, there was a huge debate in the British Medical Journal about using sperm donation. The Pope and the Archbishop of Canterbury and others labeled it as a sin and demanded that anybody involved be imprisoned. Now, as far as I can find, nobody has ever been imprisoned for sperm donation, be it a donor, recipient, or physician. I can't say that 100%, but as far as I can tell, I can't find anybody who's been imprisoned for that particular act. In 1964, we saw the first sperm banks appear for donor therapy. One of the first ones was in Iowa. And for those of you from the US know that Iowa is the hotbed of sperm donor activity. I mean, it's the center of the universe for sperm donors. For those of you who are not in the US, Iowa is certainly not the center of the world for sperm donors. They have a lot of corn. They don't have a lot of sperm banks. But anyway, that's where one of the first banks was. Also in Japan, and that's also an interesting one because today in Japan, it's not, sperm donation is not illegal, but it's not regulated well enough to be, it's legal, but it's on that fringe always. Anyway, so that's where the first two sperm banks started. But now getting back to the point, in the 80s and 90s, sperm donation became more and more common, and we saw several banks pop up, several of the big banks popped up. And the two that I'm going to talk a little bit about, is of course my bank, Cryos, and California Cryobank. So these two gentlemen that you see here, Olishko on the left-hand side of your screen, and Cappy Rothman on the right-hand side of your screen, they were kind of the forefathers of sperm donation, Ola mainly in Europe and Cappy in the US. And they pretty well, I mean, started about the same time as each other and went a long way in this field. I'm not going to talk a lot about Cappy. He's a great guy. And you see the book right there, God of Sperm, that's available on Amazon. I've read it. It's a nice book. It's worth a read if you have the time. So if you want to know more about Cappy, you can find out about him in that book. But Ola. So Ola's an very interesting guy. For those of you who've met him, you know that he's a very interesting character. He began this whole process of sperm in his mother's kitchen. He was a business major. He has a diploma of, I'm not sure exactly what it is. It's a business major. And that was his whole focus. But he had a dream one night about rivers of frozen sperm. I mean, that's kind of an odd dream. I've never had a dream about frozen sperm, but he did, and couldn't get that dream out of his head. He kept thinking about it and thinking about it and thinking about it. And he just became obsessed with frozen sperm and how to freeze sperm and how does it work. And, you know, after that, he went to his university librarian and said, can you get me every book you can find on sperm freezing, anything to do with sperm? And that must have been something interesting for the librarian to go, what's up with this guy? He's a business major and he wants books about sperm. It had to be a whole strange thing. But he kept going, and he started experimenting with his sperm, or with sperm in his mother's kitchen. Again, I don't know if it was his sperm or friend's sperm. I don't know where he got the sperm from. He just got the sperm, and he practiced freezing it and different ways to process it. And, you know, that progressed for some time. He was using a little microscope that his parents had given him, kind of a high school microscope thing, you know, like you'd see in a high school class. Well, maybe in some high school classes today you see much better microscopes, but you can imagine the microscope he had back in the 70s when he was doing this. He was able to open his first lab not too long after that with a loan from his mother. Now, go figure, his mother gave him a loan, and I kind of suspect loan came from his mother to get him and his sperm out of her kitchen. But anyway, he started with a small little 50 square meter lab that he processed sperm, and then eventually went on to open a sperm bank. And since that time, Cryos is arguably one of the world's largest sperm banks. So he did a great job. I mean, it was a big deal. And it's just amazing the work that both Cappy and Ola have done in this field. Now, when we're talking about what's going on, so the problem with sperm, when we're talking about sperm from the 80s and sperm from beyond, you know, the basic process of freezing sperm has not changed a lot since the 80s. It hadn't changed in the past 40, 50 years that much. You know, we process it or separate it or not, and then add freezing buffer to it and freeze it. You know, some people have, Cryos has automated freezing machines that slowly lower the temperatures. Other people just dip it into the dewars, slowly into the vapors, then drop it down until it freezes. But really, the process of freezing sperm has not changed that much at all in the past 40 years or more. But the things that go with it that have changed are the important things in my book. So some of the big things I'm going to talk about here, donor anonymity, that's probably the number one thing that's changed since the 80s. I'm sure everybody's aware of how donor anonymity has kind of gone away. It just can't happen these days, but that's probably the biggest change to sperm banking that I am aware of, or that I can find. In my mind, that's the biggest one. Donor testing and screening, we'll talk about a little bit. Another big change for the sperm banking world was single women and LGBT community. The advertising has certainly changed over the past 40 years, and there's an addition of the gray market, which has had a little, not impact, but it is out there, and something that we'll talk about a bit too. And then we'll finish up with some changes that we hope we'll see in the future, you know, potential sperm quality issues, freezing techniques, stem cells, and freeze-dried stuff. So again, the big thing that I think has changed over the past 40 years with sperm donation is donor anonymity. You know, in the beginning, all of the donors were anonymous. Many were medical students, doctors, or employees of the physicians. Maybe they were lab people. But you know, it was a lot of the donors were physicians, medical students, and other people that were around the practice. Donors were often too embarrassed to tell anyone. You know, they felt they had too much to lose if they were a donor and there were no protection for the parental rights. And recipients, or at least the male partner, they were often embarrassed to talk about using a sperm donor as well. You know, it kind of makes you feel like less of a man. You know, I point this out often. When women use egg donors, they carry the baby for 9 months, right? So they have to feel a connection, without a doubt. They have to feel a connection to that baby. So, you know, the donation for them, it is a donation. They know that, but I mean, it has to feel like it's their baby. But you know, for the man, it's a whole different thing. Your wife's now pregnant with somebody else's sperm. You had nothing to do with it. So, I always, you know, the guys who use sperm donors, I really congratulate them or think very highly of them, because you know, that's a big step for a guy to make, to go and use a donor versus your own sperm. So, you know, this system worked well for a number of years. Anonymous was the way it was. That's just the way it was. You could not get a known donor. Well, you could, but not really in mass quantities, but you couldn't get a known donor. But you know, then the pesky children want to know where they came from. And that was a big problem for the sperm banking industry. You know, what are you going to tell the kids? So along comes things like the donor sibling registry. And I know that most of us thought when this came about in 2000 that this was kind of a threat to the banking industry, because it was, you know, they were trying to out people. Well, I shouldn't say they're trying to out people. They were trying to to kind of get more known about donation. They were really set up to assist individuals conceived from sperm, egg, or embryo donation to make contact with their half brothers or whatever it happened to be. And it was a big deal for a long time. And then 23andMe comes along, and you're all aware of 23andMe, so I don't have to tell you a whole lot about it. But 23andMe and the other test out there, they changed the world for donor banks, because there is no such thing anymore as anonymous donor, and that's just a fact. That's okay, but there can't be anonymous donors anymore. And part of this problem was the companies were offering very low cost testing. People were giving them as Christmas gifts and birthday presents and things like that. And, you could buy it. I don't know the lowest price, but I know I saw them for $50 or something like that for the full genetic analysis. Probably even less than that. I don't know, but it got a lot of people signing up and doing it. One of the problems with this is we tell the donors, look, you just can't be anonymous anymore. We counsel the donors who want to be anonymous. We have anonymous and known donors, but the anonymous donors, we counsel them. We tell them, you just can't be anonymous. You can be in our books, but you have to know there is ways to find out. Facial match recognition, 23andMe, all these things come into play. And if, with 23andMe, a sibling or a cousin can have a test done, and they can link back to you being their father as a sperm donor. One of the problems with this was that a lot of the donors, and as I just talked about, many of the donors were professionals, doctors, laboratory people, students. They were promised they were going to be anonymous forever. That was the way it was. They were anonymous. You were never going to know who they were. Same thing with the parents. They were never going to know, and that's the way many people wanted it. But we opened Pandora's box, right, when we got 23andMe, so it's out. We can't take that back. So recipients, many of them just wanted to have the anonymity for religious or ethical or personal reasons. Their religion may not approve of sperm donation. There's many reasons why they didn't want to disclose to the children that they were donor conceived. And there are still children today that are not told, right, wrong, or otherwise. The parents feel that way. It's not a call that I can make that you have to tell somebody. Again, I think I agree that, they have the right to know where they came from, but, there are still people out there in this world that just don't want to disclose that to their children for whatever reason it happens to be. And that's a whole different topic. That's a kind of a ethical issue more than anything else, but a whole different topic from this. But the big winner are the children, with the advance of the donor sibling registry and 23andMe, banks were pretty much forced to begin non-anonymous or ID release specimens. I wouldn't say we were forced. We knew this was coming, so we started doing it anyway. But, it was really a little bit of force to it because it was coming, and whether we liked it or not, it was going to be there. So that's the way we got around it. We started offering ID release donors. Most of the banks out there still take anonymous donors. We do as well. We give the donors the opportunity to select whether they want to be ID release or anonymous donors. And, I get questions all the time from places, people ask me, how come you don't just do ID release? How come you're still doing anonymous donors? There's a couple of reasons to that. One reason is, again, some people just don't want to tell. And again, I'm not the one to judge whether they need to tell the child or not. That's a whole nother issue. But there's also countries that only allow anonymous donation. So we still have to fill that need as well. So we still take anonymous donors as well. The rules for the release of information about donors comes at it depends on what country you're in. Some countries, it's 16 to 20 years old. There's a few other countries, one or two other countries that know from the time they conceive who the donor's name is. But most right now tend to be between 16 and 20 years of age. When the donor child reaches 16 to 20 years of age, they can find out the information about the donor. Now, whether or not that includes contact with the donor, that varies by bank and also varies by donor. Cryos, we allow them to They can contact the donor. Whether the donor wants to contact them back and be in contact with them is up to the donor. But we offer that option. Some banks also make it a requirement that they are, once they meet them, they have to have some contact with them. So, but again, anonymous donation is still required in some parts of the world. And to me, that's kind of bizarre. I know in some places, you know, you go in and you want a sperm donor, the doctor walks back to the freezer, picks out a specimen and comes back and says, I got the perfect donor for you. That's just kind of strange to me, but it's just, you know, that's the way other parts of the world are. One of the next things that I would like to bring up for sperm banking, you know, a tremendous boon to the sperm banking world has been the addition of LGBT community and single women. I was looking back to find out when it became legal for single women to do home insemination or any insemination, and I couldn't find that. You know, I don't think it's ever truly been illegal. And I can't really find when it started to be a commonplace thing either. But, you know, there are really a few places in the world that don't allow single women. I don't think there's any really that don't allow it. But I just did a recent search. I looked at some stuff, and these are mainly first world countries. But or I have to move something here because I can't see my screen. Sperm donation for single women is legal in 14 of 28 countries, and 2 more very soon. Now, again, these are first world countries, but that's kind of nice, right? You got 14 out of 28 countries that allow single women to use sperm donation. Lesbian donation or LGBT donation is legal in 15 of 23 countries, and probably legal in 3 more. It's just hard to say. They list as a married couple being legal, but other places list heterosexual married couples. So it's up for grabs whether or not it's truly legal in the other 3 to 6 countries. But anyway, it's becoming more and more. You know, the good thing for sperm banks about this is lesbians and single women don't have infertility numbers any greater than the normal population does. So most of the people coming to us don't have infertility issues. Their only infertility issue is they don't have a partner with sperm. So, you know, it's a huge win for us. And I will tell you that in Cryos, we sell about half of all our sperm sales go to home insemination, be it single women, lesbian couples, or even heterosexual couples who just don't need to go to the doctor for treatment. Another big one that has changed, and this is another one that hasn't. It's changed, but it hasn't changed. So not much has changed in terms of testing and screening for donors since the 80s. It really hasn't. We test for the same things: HIV, hepatitis, chlamydia, gonorrhea, syphilis, all those fun things. It just really hasn't changed. The big thing that has changed is in the 80s and 90s, we relied heavily on serologic testing, and now things have moved to mostly molecular testing, so mostly NAT testing, and it's much more efficient, much more accurate, it's much quicker. You know, in 2005, the FDA began regulating reproductive tissues under their directive, and nothing's changed since that time. It was written in 2005. It's still the same today as it was in 2005. The EU directive came out around the same time. It's very similar. It's changed slightly, but not that much either. They also all address emerging infectious diseases such as West Nile virus and Zika. But those have been really the only changes. The other big thing for me with testing is there's no worldwide standard. Just speaking from a U.S. point of view, the FDA doesn't care about genetic testing at all. That's not something they're concerned with. They're only concerned with infectious disease. You know, we know more today, and I think it's time for an update of the regulatory document. Again, they haven't kept up with the methodology. Does the U.S. really need to quarantine sperm for 6 months and then retest the donor before it can be released? What's going to pop up in 6 months' time that won't pop up in 30 days' time? You know, mostly in Europe, there's a 30-day quarantine, not a 6-month quarantine. In the U.S., you can't donate sperm if you're a gay man and have ever had sex with another man, but you can donate blood if you haven't had sex in the previous 3 months. And that's just changed. Actually, it's changing, I think, the 1st of next month to there is no time restriction. They're treating everybody the same as anybody else. So whether you're a man who's had sex with another man or just a regular blood donor who's heterosexual or whatever it is, you'll just be tested. If you test negative, you can be a blood donor. but the regulations haven't followed course. Normally, the tissue regulations do follow the blood. In this case, they haven't followed the blood. So we'll see what happens. Maybe down the line, we're going to get a total rewrite of the regulations. But right now, if you're a man who's ever had sex with another man, you can't be a sperm donor. Technically, you can if you've not had sex with somebody, and I think it's either a year or 3 years or whatever it was. But still a long time to go in between not having sex if you're persuaded to do that. Same thing here with chlamydia and gonorrhea. This is a weird thing in the U.S. If you've had chlamydia or gonorrhea, you have to wait 1 year after treatment to donate sperm. Again, blood is only 3 months. Once you're cleared of chlamydia and tested for it, I'm not sure why you have to wait a year to do that. If you've lived in Europe for more than 6 months, you can't donate sperm in the U.S. Why? CJD and TSE. Blood donors, they're not disqualified for this. The only way they're disqualified is if they've been diagnosed with one of these diseases, have an immediate family member, or if they lived in the UK in certain areas. Well, mainly all of the UK, but nonetheless, there's a huge disparity between blood regulations and sperm regulations and reproductive tissue regulations. In today's world of modern technology and molecular diagnostics, it's really crazy that we still have the same regulations that we have. And again, there's just no reason why a person who has chlamydia needs to wait 12 months after treatment before donating. Same thing with men who have had sex with another man. And again, if you live in Scandinavia, you can't donate to a recipient in the US. It just doesn't happen. So while there's been little changes in terms of what we test for, we really do need some big changes to the regulatory statutes. Another thing that's certainly changed over the years with sperm donation is the way we advertise. Back in the 80s and 90s, college newspapers, and I'm imagining there's probably people in this webinar right now who've never seen a college newspaper. I'm not sure that colleges even put out print newspapers. I'm sure you can find them online or something like that, but I'm guessing colleges don't print newspapers anymore. But that's the way we used to get donors. College newspaper, handbills, word of mouth. That was the way in the 80s and 90s that we got donors. Most of the sales were done through the physician offices. So you didn't really need to advertise to people, or there was not a good way to advertise to people. So most sales just went through the physician's offices. Today, everything revolves around social media. And, I can say, while I said earlier, I'm not an old guy like Kim, I look at these 4 things here: TikTok, Instagram, Facebook, and Twitter. I've been on one of them, and I don't know anything about the rest of them. But anyway, that's just me and not everybody else. But today TikTok seems to be the choice for us getting donors and finding influencers to help banks sell. Conversely, the Facebook and Instagram are where we find most of our recipients. So it's very interesting the change that we've had over these years and the aspect that social media has brought to us. Years ago, it was tough to get enough applications by advertising through newspapers and word of mouth. We accept about 3 to 5% of all the people who apply to the banks. And that's not just Cryos, that's pretty much across the board in the US. Social media, one great thing that's happened is we can get thousands of applications. The problem is we get thousands of applications and we still accept 3 to 5% of the applications. So while it's increased the number of applications we get, it's also increased the amount of work to sort through them and find a suitable donor. Last thing I kind of want to talk about in terms of what's changed, the gray market. I don't know how many of you know what the gray market is or have an idea of it, but gray market is basically Facebook or Craigslist or whatever you want to call it, donors. People go on Facebook or whatever it is and sell their sperm. They often advertise that they can personally inseminate you, or they can provide a specimen in a cup for you if you like. And you can use the turkey baster method. And I will tell you the turkey baster method works pretty well. That's what they use for the home inseminations with our sperm as well. But the vast majority of these donors are not screened or tested according to donor standards. So, if they're selling sperm that could potentially be very hazardous to somebody, could cause either birth defects, or they could be, they have chlamydia, whatever it happens to be. They're just not screened, and they're not up to the standards that we would expect donors to be up to. One other thing I can tell you is that donors on Facebook and Instagram or whatever, they're not always truthful and not always honest. Lots of times they use forged documents, often stolen documents. And I can tell you, we've had a couple from Cryos that people have stole the summary of record report and modified it to look like it belonged to them. And we're using that. And I've had people report that to me and they said, look, we found this guy on Facebook, he's doing this. And it turns out it's not even the donor that the SOR was created for. So, you just have to be very careful if you're looking on the gray market. You also have to be careful about the legal aspects of it because they may have some parental rights. Without a contract, you just don't know. So all around, I find the gray market to be a very bad thing. What's the future coming up? Well, I think the big future for us is the quality of the sperm that we freeze. Not the quality of the sperm itself, but what we're freezing. Is there a way that we can sort out sperm to freeze a better sperm product? It only takes one and we have millions, but if we can freeze a bunch of ones and not just millions of other sperm that aren't doing anything, that'd be a good thing. So we'll see where that goes. Hopefully it's coming. Products like Zymot are already doing a much better job of separating things for us. They seem to be a very good product. They put out good quality sperm once it gets through the filters. And, we'll see what comes of that. I think there's more to come. Also, media companies are starting to pay a lot more attention to semen these days. And for those of us who have been around for quite some time know that comes and goes. It'll be a peak where they'll do a lot of research on it, and then it'll trough and peak and trough. So we're back in a peak kind of period with sperm, I think. We're seeing a lot more development on that stuff. And, things like, can antioxidants aid the freezing and warming process? Things like this, who knows? But that is probably some of the future stuff that we'll be talking about. Maybe if we have this meeting again in a couple of years, we can talk about a few of those things. And I love this picture. This is a picture that you can see this almost every time SpaceX launches a rocket from where I'm at right now. We get a giant sperm in the sky, and I think it's very, very cool. I love to watch it. But the next things that we're talking about is vitrification. Is vitrification coming to sperm? Yeah, there's been some research on it. It's getting there. I think a big factor with that is the volume that needs to be frozen for donation. So we'll see. We'll see where it goes. It's certainly changed the world of egg donation. We wouldn't have frozen egg donation or frozen banks without vitrification. So there's a lot to be said for vitrification. We'll see where it goes. Freeze dried. Don't laugh at this. They're doing this in mammals, and that could solve a lot of issues for sperm banks. It's much easier to ship something at refrigerated temperature, 4 degrees, than it is to try and maintain it in liquid nitrogen using a dry shipper. So there's some potential there. And of course, the last thing, and the thing that I think is probably going to be the biggest factor, although I don't think it's going to be anytime soon. I don't foresee it in the next 5 to 10 years, but it's not that far off that we're able to develop a sperm cell from a stem cell and have people use their own cells to create sperm. So, for example, a lesbian couple, if they took a stem cell from one partner's arm and used it to inseminate the other partner, that would be a big deal. For heterosexual couples who have male factor and don't produce sperm or whatever, that would be a big deal. You could actually continue on your own progeny. So I think that's probably the future that is the biggest thing for me. I think that we're going to see stem cells come about and provide a good product for us. So, all right, guys, thank you very much for your time, and it's been nice.
Thank you, Corey. That was an absolutely fascinating talk. I'm hoping you can hear me.
Yep.
Yep. Okay, great.
Sure.
And what was interesting about your talk is really you talked in the beginning about freezing sperm, and sperm I think are always perceived as being incredibly robust in comparison to freezing eggs or embryos, and I guess a lot of work has been done on freezing medium and different ways of doing it. In the early days, as you've already stated, we literally used to put a bit of culture medium in, put a bit of serum in, and suspend them somewhere in the liquid nitrogen tank that we felt would give good results. You've now talked about the future as well, and it's great to think of all the things that we might be doing in the future. And that all the regulation that's developed, particularly from when I started, from when there was no regulation to really heavily regulated now. And in the early days, one of the great problems that we had was tracking down where our donors went to, because we tried to limit the number of pregnancies per donor. But of course, as you know, the donors would skip to another town, and there was a big call in the UK to register under NHS numbers, such that they couldn't do that. So very, very fascinating parts of your talk, and I know there's going to be a lot of questions in the Q&A section, and also there's some thoughts about when we're on the slippery slope. Again, in the early days, we would only match the donor to the partner of that person, whereas of course now there's so much detail about the donors, and as we know, anonymity is effectively gone. I mean, how do you feel about the possibility that the fact that now it is pretty open, and you can select pretty well whichever donor you want? Again, how do you feel that comes into it?
Yeah, I mean, I think it's a good thing. I think that, so I'm comfortable with non-anonymous donors. I think it's a great thing. I think that it provides a lot more opportunity for the recipients to select who they want and find out more about them. And, you know, if you've been involved with the donor process, you'll know that the recipients are so picky these days. I mean, they'll go through, they'll pick a donor based on, you know, whether he played trombone in the band or something like that. So it's a minor factor. You know, everybody wants a donor that looks like them. That's the first and foremost thing they want. But it's just odd, the number of things now that they get down to details. And I think one good thing is I think we have more donors today than we had previously, barring the COVID scare for the little bit, couple of years that we had limited number of donors. But I think today we're back to the same numbers we had before. And actually many more of them now are ID release or known donors. And I think that's a great thing. I think it's best for the children. I think it's best for the recipients. But I also believe that there is that segment of population who still wants anonymous donation, doesn't want to think about who the donor is or know anything about the donor. And again, that goes back to whole ethical debate, whether it's you know, and I'm not one to say whether it's right, wrong, or otherwise. I think the best way is non-anonymous donation, but we'll see where that goes.
Thank you. We had a very interesting case in the early days of a couple where the gentleman was, I think, about 5'4" with ginger hair and wanted a 6'2" dark-haired donor, which was very difficult when we had this policy of just matching to the donor. But right. Thank you very much, Corey. That was
thank you very much.
And I can see that there are lots and lots of questions piling up for the Q&A session. So I'd like to introduce our last speaker, a very eminent gentleman who really needs no introduction. The founder of i3, of course, Jacques Cohen, who's a renowned reproductive biologist and clinical embryologist, and I think somebody that we all aspired to follow, and I certainly did. He's made significant contributions to the field, from his early career in the Netherlands to working with pioneers, of course, like Bob Edwards and Patrick Steptoe in the UK. He directed esteemed embryology laboratories and co-founded the innovative startups such as Reprogenetics and Life Global. With over 300 publications, which is impressive, textbooks, and 14 patents, he founded and serves as Chief Science Officer for IVF 2.0, hope I've said that correctly, Jacques, spearheading advancements in AI-driven IVF products, and Chief Science Officer for Conceivable, involved in robotics technology. Made an amazing contribution to our field, for which we are all very grateful. But Jacques, you're going to talk about the history of male infertility and fertilization in vitro I'm sure it'll be a fascinating talk. Thank you.
Well, thank you, Karin, for this wonderful introduction. I'm very happy to be here and present this particular topic on andrology, the second lecture on andrology today, because the 1980s were instrumental for the changes that have occurred in andrology and male factor infertility treatment. So thank you for this kind introduction, and thank you I3 and Giles Palmer and everyone else for this invitation. Here are my disclosures. History is an inexact science. It is astonishingly inexact. And so when you hear a history lecture or a lecture, even that is about a relatively recent period like the 1980s, you'll be left with impressions of truth, but they're just reflections in time. And so I have to start somewhere, and I'll start very carefully and just for a few minutes with the two people that have been instrumental with so many others for finding the gametes that determined what fertilization was all about, the reproductive cells that were involved. They didn't use those terminologies. They would talk about generation instead of reproduction. And that's first of all is Anthony van Leeuwenhoek, Antoine as he was called, a gentleman scientist. He had other professional duties as well. And he was a lens expert and developed a microscope that was so much better than any other microscope that existed at the time in Europe. And he could get to about 200 times magnification. And in 1677, when he saw microbes from a little bit of water that was taken from the street, he thought, well, the next day he did what I think most scientists would have done. And he looked at presumably his own semen and seminal plasma, and found spermatozoa, who he described as little animals, and thought that they were microbial in origin. It was understandably, at least for a while. By the time he got closer to his death, years later, he changed his mind apparently, and thought that these little animals had something to do with generation, with reproduction. The other one is Carl Ernst von Baer, and you see this. You can see probably this nice picture, these nice drawings on the right side. In 1827, so that's 150 years later, after the discovery of spermatozoa, he was the first to describe the the oocyte, mostly from non-mammalian species, and also the first to describe blastocyst, the first to describe cleavage. So that was all done in 1827. Amazing work done by this Estonian scientist who practiced most of the time in St. Petersburg, or near St. Petersburg in Russia. And he also described, gave a name to our field of andrology, named to the gamete, and called them spermatozoa. But also he, like Anthony van Leeuwenhoek, believed that these were not necessarily generational cells. He also believed that there was some kind of parasite, but also he changed his mind about that later. And so from then, at that point, you have spermatozoa and you have eggs. The whole debate started. What do these two cells do together? Are they involved in generation and reproduction? And that was really ultimately shown, and I skip over about 30, 40 years here, but ultimately shown by Oskar Hertwig and confirmed by several other scientists like Voll and Schenk in Vienna. It was Hertwig who showed the principles of sexual reproduction by studying sperm and eggs from starfish. So that was 1876, about 100 years before Louise Brown. So at that point, things went very, very, very fast. So we skip some years, because I've been showing you for the first few minutes pictures and findings of men. Now, women certainly had contributions, but they were not allowed to study, or at least not in Western countries. They were not allowed to study. They were not allowed to become professors at universities or scientists. That only changed at the end of the 19th century, and only very, very, very slowly. So here are 8 who have been involved in our field, all the way back to 1900 with Nettie Stevens on the top left, who discovered the Y chromosome. Isn't that interesting? One of the first women in reproductive science who discovered the Y chromosome. She was quite astonishing. She was from the United States and studied at Bryn Mawr, never had really a full faculty position anywhere, and did most of her work at the Stazione Zoologica in Naples, Italy. And there are others here as well who all have had their imprint on andrology aspects. And I particularly like to mention Bruce Fowler, obviously the spouse of Bob Edwards, who was involved in the very early follicular stimulation experiments in the mouse, together with Bob, and produced fundamental papers that helped the team of Edwards, Steptoe, and Purdy to do their first experimentations. And of course, there are many others involved as well. Some of you whom you will probably know, like Lucinda Vick, who was the first independent clinical embryologist who established the first IVF clinic in the United States. Now, the concept of the infertile man is unreported until the 1920s. Of course, it was known, but it was sporadically discussed. It wasn't really a field. That changed about 100 years ago. Routine semen analysis, on the other hand, is only from after the World War. And it was particularly McLeod and Hotchkiss. They were particularly the people who made this into a science. Semen cryopreservation, as Corey just pointed out, is from the 1950s. And indeed, Iowa played a major role there. John Rock's editorial in the New England Journal of Medicine, which was not signed in 1937, about the process of ectogenesis, which is what Haldane described in 1923 as a prediction of the possibility of IVF. It was John Rock, a Harvard professor, who said, well, this would be really a boon for the barren woman. Not thinking about any other aspects of infertility. Obviously, he was already reaching very far. He was reaching out to promote in vitro fertilization, or the process to have the fertilization process outside the body. And this was considered very daring, and he didn't sign his editorial. But the focus was very much on infertility in women, well into the 1970s, when Steptoe and Edwards did most of their experiments. In the 60s and 70s, there was a lot of basic science being done in our field, also on sperm-related factors such as sperm maturation, ecosome reaction, penetration into the egg, fusion, nuclear formation, centriolar contributions. All of these have been studied in great deal in the 1960s, 1970s, and also the 1980s and 90s. There were no viable alternatives for treating male factor infertility before 1980. Now, this changed with the advent of IVF. So in 1978, it clearly changed. And in the 1980 paper, that was a full-length peer-reviewed paper, I think published in the British Medical Journal, Edwards, Steptoe, and Purdy, authors, said there seems to be no reason why similar methods of IVF and embryo culture treatment should not be applied in cases of infertility arising in some men with oligospermia, because so few spermatozoa are needed for fertilization in vitro. And so that was an important statement. And they immediately started doing that. They immediately, once they opened Bornholm Clinic, they started looking, they didn't turn down men who had very few or abnormally shaped spermatozoa. Now, quite a few scientists and doctors reacted cautiously about this. And that was based on feelings or it was just basically a knee-jerk reaction. The fear was founded in terms of anomalies of somatic cell morphology, because in somatic cell morphology at the time, it was believed that abnormally shaped somatic cells and cells with differing physiology have classically been associated with disease. So there wasn't really much support when they started looking at male factor, but there was interest from almost all clinics that started IVF in the early 1980s. So the three people involved had a background in andrology. Patrick Steptoe's background was clear. He described in his book that he co-authored with Bob Edwards, Matter of Life. He describes that he was visiting with or studying under medicine, obstetrics and gynecology, under Mr. Gwilym as a registrar just before the World War. And it was Mr. Gwilym who told him 1/3 of all infertility is male factor derived. And that struck him as extraordinary, because in medical school, he would never have been told anything like that. That was just not discussed. So that had made an impression. So he certainly was, I would say, a fan, a support in terms of attracting male factor infertility patients to their work, first in Oldham and then later in Bournehall Clinic. But Bob Edwards was an andrologist in a way. He was also a geneticist. He was also a physiologist. He obviously was a clinical embryologist. But he published about 60 papers on sperm-related aspects, starting in the mid-50s with Dr. Serlin in Edinburgh. And in between 1955 and 1957, he had 3 papers in Nature on sperm function, all to do with their studies that were done in mice. So he certainly was very interested. And so was Jean Purdy, because when she became part of the team in around 1970-71, she felt that improvements were needed, particularly in terms of sterility and taking care of sperm preparation. And sperm preparation was a fledgling field at that time, and got certainly better in the 1970s. And I must say, I'm sure David Mortimer is in the audience. I saw him there on the list, who is not only 80s famous, but also 70s famous. David Mortimer was deeply involved in that type of work and studies of andrology as well. So Jean, Patrick, and Bob were very much interested in male factor infertility. Now, the first cases were presented at the first International IVF meeting in Bournehall that took place in the summer of 1981, not that long after Bournehall opened. And they invited about 20, 30 pioneers in different countries and discussed their male factor infertility findings. And these proceedings were published a year later in this book edited by Edwards and Purdy. And it was Simon Fischel who presented at this meeting. He had just joined and was the first embryologist after Bob Edwards to join the team. Both Carol Verheely and myself joined about 8-9 months later. So Simon presented this work, and he presented that there were 8 cases done, 5 with fertilization, that the fertilization rate was 42%. They reported on 2 births. They did not report that they have poor record keeping, but that conclusion can be drawn when you read the chapter. And indeed, when I got there as someone interested in male factor fertility and andrology, I felt that the sperm record keeping was somewhat suboptimal. They would report on final concentrations of the sperm prep rather than what the counts were in semen analysis. The semen analysis was often also incomplete. And as any other cases, there was very little or no follow-up. That really started much later from IVF clinics. That initiative wasn't there. IVF clinics were completely overwhelmed just doing one case, let alone doing several cases at a time. Another person who was involved in this early work, together with his colleague Maha Mahadevan, who is in the audience, and I couldn't find a picture of Maha, otherwise I would have definitely put that up. This is Alan Trounston, who initiated that work with Maha, and they described, Alan did at the meeting in Bournehall in 1981, they described that they also treated male factor cases with modest success, and later followed it up with the first publications, peer-reviewed first publication on the treatment of male factor with IVF, not with anything to do with ICSI, but with IVF. This is more than 10 years before ICSI became successful. And so others documented it as well, but it was only success in terms of fertilization that was achieved at Bourne Hall and Monash University in those first 2 years. The first case series reports were published. This was ours. It found a basis and was pointed at quite a bit. And that's probably more because of the title than the content, frankly. The first case series of male factor was only 41 patients. I must say, in hindsight, it felt like a lot more. The incidence of transfer was 75%. In other words, vitro fertilization had a failure rate in those men of 25%, quite astonishing, actually. The pregnancy rate, nevertheless, was 33%. That was calculated at the time by embryo transfer. So the pregnancy rate was a fourth lower than what you see here. And that was not the ongoing pregnancy rate or the live birth rate. A second group of 61 patients had male and female factors combined, and the pregnancy rate there after transfer again was 26%. Those sound like terrible data, but that was considered among the highest in the world at the time, at least from publications that people could compare with. There was no registry in the United Kingdom at the time. There was no registry anywhere at the time. That came about 3, 4, 5 years later. The emphasis very much to do this work was on sperm preparation. How do you do sperm preparation? How do you concentrate the spermatozoa? It was also related to repeated collections. So we would collect sperm every other day. Split ejaculation was practiced. Optimization of insemination was looked at very carefully. So the results were not bad, but it was just early on. And it was felt that improvements were needed, that we needed to tinker with the process, using micromanipulation as a basis. That had already been thought about years earlier, but it hadn't really been tackled. And there were disappointing results that were published by various investigators in the mouse, trying to stick spermatozoa into the egg directly, a process that we later called ICSI, or that the Brussels group called ICSI in their publication in 1992. So the fertilization process, what could we do about it? How could we get the sperm in there? And so there were several approaches that were proposed. This is from a chapter in a book called Andrology. And here's everything combined in one particular cartoon. You see zona drilling. That was the first proposal, using acidified solution, making a hole in the zona pellucida. Those holes will be round. Tissue was removed from the zona pellucida, and then putting this egg with an opening in it, putting this egg in a suspension of spermatozoa so that those could find the hole and swim through. So it was thought that maybe the zona pellucida was a barrier to fertilization. The second procedure that was an alternative to this, and I'll come back to that, is called partial zona dissection. And partial zona dissection is actually really doing the same, of making mechanically, not using pH changes, making mechanically a slit in the zona pellucida. So that's actually, if you look at it from above, a slit, whereas the zona drilled hole looks like a hole. And then, of course, there's the SUSI procedure, subzonal insertion of spermatozoa, and that was either done with several spermatozoa or sometimes done with a single sperm. And finally, the ICSI procedure, bypassing both the membrane as well as the zona pellucida and directly injecting a sperm in the middle of the ooplasm. So these procedures were done and looked at from 1986 to 1992. So 6 years before the first ICSI publication, this was looked at. And there are reasons for why it took so long to get to ICSI. We wanted to be careful, and it seemed to us at the time, investigators that both zona drilling, PCD and SUSI, were less aggressive than ICSI. Interesting in hindsight, but then, hindsight is interesting. The first paper that was published, a favorite, was published by Professor John Gordon and his PhD student Bess Talensky from Mount Sinai School of Medicine in New York. It was published in 1986 in the Journal of Experimental Zoology. It was hiding for a few months before people in the clinical field could actually pick it up. The title is Assisted Fertilization by Zona Drilling, a mouse model for correction of oligospermia. It was important for our field because two things had been done here. microsurgical fertilization in an animal model for the first time, but also a mouse model. This was a validation study, something that was really very rare up to that point in clinical IVF. They showed a low damage rate of less than 5%, a low rate of polyspermy of about 2%, a very high rate of normal fertilization of 75%. And then when they reduced the concentration of spermage, they kept at about 1 million per mil. When they reduced the concentration to 10,000 sperm per mil, where interactions of sperm and eggs were really reduced, they also showed fertilization and no fertilization in zona intact controls. There was an uncontrolled number of spermatozoa in the perividinous space. They found eggs where there were as many as 10 or 20 sperm in the perividinous space, and sometimes eggs there were none. But usually there were more than one. And so they could conclude, since the rate of normal fertilization was so high, that the block to polyspermy in the mouse resides on the O lemma and not the zona pellucida. That was an important finding and an impetus for certainly my group at the time. And at that time, I was at Reproductive Biology Associates in Atlanta, Georgia. And I was interested in seeing whether this could work clinically. After this paper that was published by the Mount Sinai group, they did another paper and looked at doing this after they got ethical board review. They looked at this in the human, and they found that the total fertilization rate doing zona drilling by reducing the pH was 25%. But half of those eggs were not fertilized normally. They were fertilized, but multiple sperm had penetrated. So half the eggs were polyspermic, the other ones were monospermic, reducing the fertilization rate, normal fertilization rate, to 12.5%. They did a few embryo transfers, but had no pregnancy. We, in the meantime, before seeing this paper, had done the same and also found no pregnancy from doing zona drilling, and found when we left spur embryos in vitro that those would not develop the blast system. Once we replaced it with partial zona dissection, they did develop the blast cyst. And so that's how we thought, well, maybe reducing the pH on the zona pellucida of a human egg could be potentially detrimental. At least that's what we postulated. It was somewhat proven later in another study, showing that microvilli were affected on the O lemma if the pH was reduced locally. So from this work, they and so did we concluded that the polyspermy block in the human was on the zona pellucida. It wasn't like the mouse and some other species as well. It wasn't on the O lemma. In other words, when you open the zona pellucida, even just a little bit, it's like opening the zone, taking the zona pellucida away. You get massive polyspermy. That should have led sort of to an end of the procedure. But then subzonal insertion came around and made a difference there. We did take the mechanical procedure to a clinical trial, and that was done with Henry Moulter, who I've worked with in 5 different clinics, in 5 different institutes, I should say. Henry Moulter, you can see here on the left, who, if you look at his LinkedIn page, you'll see that he is still in the 1980s, flamboyant outfits, even painted shoes. Quite a character to work with. It's been a real pleasure, and maybe he is listening, and I hope he does. So Henry Moulter was instrumental in setting up the micromanipulation system so that it could work appropriately, and we tinkered with that quite a bit till it was all achievable. So we reduced the pH with zona drilling initially. That didn't lead to blast cyst formation. Then we did partial zona dissection, PZD. And we got 10 out of 16 fertilized versus 4 out of 17 in the controls. So we had permission to do a small sibling oocyte study. It was tiny, but we had 6 patients with 4 transfers and 2 pregnancies, and some of these transfers were mixed. And that letter was published in The Lancet on July the 16th, 1988, so 10 years after the birth of Louise Brown. So that was kind of a very modest beginning of assisted fertilization in the human. So Henry and I would give courses and teach others how to do these fledgling techniques. And Henry would give a pep talk about this and always talked about the 3 P's. The P of practice, the P of patience, and the P of profanity. You need all 3 to become successful if you have to do micromanipulation. And Kim Pomeroy pointed it out just a little bit ago, because you had to do your own, not only did you have to set up the whole system and get that right, but you also had to make your own microtools. And that was, well, I would think more than an art. That was pretty difficult. And to do that consistently was very, very, very hard. That was replaced some years later in the 1990s by commercial outfits who were able to take this particular burden out of our laboratories. An important thing that was done. In the meantime, at Monash University, Andrea Laws-King from Alan Trounson's group, together also with Henry Southampton, were able to fertilize human oocytes for the first time by microinjection of a single spermatozoon on the zona pellucida. And that was published in 1987, so a year before those PCD patients were announced as pregnancies. But they had no permission to transfer those embryos. They obtained 12 oocytes from 5 patients, fertilized 5 of them, but there was no attempt to transfer. They were stained, those eggs were stained and investigated. Nevertheless, 3 months after we published our letter to the Lancet, another letter to the Lancet came from Singapore and from Dr. S.C. Ng and his colleagues Arif Bongso and Henry Southampton, as well as others. And they did a single case study, had 5 mature eggs, fertilized one of them, and transferred that one fertilized egg with zygote interfallopian transfer. Quite a feat, really, when you look at that whole, that particular patient and the work that was done at the time. And that patient became pregnant and delivered. Now, there is other extras of 80s famous. There was the first epididymal sperm retrieval in 1985 by the Edinburgh group. Sorry, by the Monash group, Temple Smith, Johnson, and the Gretzer were involved, and others. In 1988, the first fertilization of microinjecting into ooplasm in the human, so an ICSI-like paper published by Lenzendorf and co-workers in Norfolk, Virginia, and work that was done in 1989, 1990, that was published for the first time. There was the availability of doing density gradient centrifugation using Burke and also Savadex columns, and combine those with swim up or just centrifugation as such. And that was an important change in the repertoire of preparing sperm for microsurgical fertilization. And then Iritani in Japan published ICSI in rabbits with a very poor success rate. It was ignored by most people in our field, and particularly by the Brussels group, who ignored this as well, or at least found very quickly, once they started doing ICSI in 1992, very quickly found that this particular procedure worked very well in the human. They published this in a full report, published it in the Lancet. The senior author, well, they're all senior as far as I'm concerned, but the first author is Gian Piero Palermo. And this was achieved in 4 patients. They had 47 mature oocytes, 31 were fertilized, 15 replaced. There were 4 pregnancies and 3 deliveries. And you can see the authors here on the bottom right. So in conclusion, 80's famous. Well, art, as the saying goes, is made in hindsight, and that also is for assisted reproductive technology with capital letters. It's made in hindsight. So it's kind of, you wonder when you look back why we hadn't done things quicker. But this is how it went. We had to do this very quickly, very carefully. We had to be, we couldn't really attract patients by the thousands to do these very experimental procedures. The first proof of fertilization severe male factors from the 1980s in a mouse model validation by Dr. Gordon. The first micromanipulation for clinical embryology provided us the ability to use cameras and to teach others micromanipulation procedures, but also regular embryology procedures. The first CASA was done, and the first publication of that was by David Mortimer in 1988. Technical issues such as suboptimal microneedles were really, what were the reasons why ICSI was successful and everything before it was not, or less successful? And the most important reasons are, one is physiological, and the other one is technical. The microneedle that was developed by Hubert Joris from the team in Brussels was astonishingly beautiful. It had thin, much thinner glass. It was very sharp and very consistent in the production. And that needle was developed, and that was an eye-opener. It sounds like a minor detail, and maybe it was, but it's something that others, including our group, had not accomplished. We had needles, but they weren't sharp enough. They were dull. And when you did ICSI with them, which we tried quite a few times, the sperm, sorry, the oolamina would either not break, and if it did, it would cause high rates of degeneration. Yes, we did have fertilization from ICSI before the Lancet paper from the Brussels group, but it was not an efficient method in our hands. The other problem was, well, why did subzonal insertion and why did PCD not work well enough? And that was because of the polyspermy block that in the mouse and human are very different from one another. So monosperm fertilization and follow-up PCD and Susie papers, larger series were published before 1992. And these fertilization rates really never got much above 30%. Monosperm fertilization, most of the time, was between 20 and 30%. And once ICSI was published, that immediately doubled. And so evidence-based was unnecessary. There have only really been two papers or two moments in assisted reproduction where evidence was unnecessary. Doing patients who would just not become pregnant, and IVF was done and made them pregnant, and then later ICSI. There really is I don't think any other major technology in assisted reproduction that has changed things so dramatically as ICSI did. The first studies of laser for zona pellucida opening were carefully done by the team at the Beckman Laser Institute in California in 1989. Micromanipulation led to the improvement of the inverted microscope and its application to IVF. Acidified solution and micromanipulation tools were also used for the first PGD cases, and this was done by Steve and by Karin and by Giles and by Joe, at least by their group, of course involving Alan Handyside and others. That similar technology was applied and successfully, and that probably did make some difference to the team because they could see that there were appendices for micromanipulation. And that paper was also 80s famous, published in 1990, but the case was done in 1989. There were other aspects as well, such as improved implantation after zona drilling, VZD, which in hindsight can be debated. It led to assisted hatching in 1990. Finally, there's this list of my collaborators in the 1980s. I would love to talk about each of them, but of course, you would fall asleep if I did. So I'm not going to, but they're listed here, and I acknowledge all of that, what they have done, and I apologize if I've left somebody out. But anyhow, I'd like to finish with this. I think over to you, Steve.
Okay, thanks a lot, Jacques. Excellent talk, excellent. For us that we lived through this period, you sometimes forget how quickly things moved and how important every publication was at the time, and it was all revolutionary, and we had to go back and we had to start making other glass pipettes to slice open the zona, and it was amazing. Hearing all this together as a summary is it just brings back so many so many difficult nights where we were sitting down trying to make things, and you'd spend hours trying to get things to work, and suddenly they work, and you'd be there most of the night carrying on because you couldn't leave it. Amazing, amazing, amazing. One thing that I think we forget during this period as well, we weren't so good at stimulation protocols. So quite often you'd have a failed FERT, and you couldn't understand if it was the sperm or the eggs which was responsible. We had PCO cases which we had no fertilization, and with a moderate to low sperm, and you never know which way to look at this time. I'm not sure in the end if ICSI, this is for you, Jacques, did ICSI do us all a favor by being so successful in 1992, because we stopped examining the male, and male factor was suddenly pushed under the carpet because we had an answer for these people. But we stopped looking at treating the male, and I think it pushed us back many years. What's your feeling on that aspect?
Yeah, I totally agree. I think we've all mentioned this many times since, that that we left behind an entire field of science and an opportunity. But that's not only the case for male factor infertility, it's the same for all other forms of infertility. Because what do we do with assisted reproduction? You treat, you become successful, but the patient is still infertile, or most of the patients are still infertile. It doesn't have to be just male factor. Now, you sometimes see that pregnancy can cause a difference in women. And so you see, I mean, not enough papers, I think, about follow-up where as you know, you do a patient 5 times and then she becomes pregnant spontaneously either after a short time, but often also a longer time. So there's a lot going on here. There's also the issue of chance. But IVF, as some authors outside our field point out in papers, does not treat infertility. And because of the incredible success of ICSI, as you said, the incredible success, it went from 20-30% to 60% fertilization. And in the years after that, it went to 80% fertilization. Mm-hmm. Because of that incredible success, we are not even bothered with semen analysis very much. That is not right, because there are things we miss if we don't study man. And still nowadays, I mean, most infertility clinics don't have andrology doctors on staff. We have andrologists, but they're technicians. We don't have andrology doctors.
Okay, thank you very much. Thank you very much. Carry on with your question and answers, people. To keep the questions
we got to jump into the question and answer session now, because we've had some great talks, and I want to sort of go back to Kim, if Kim is still with us, hopefully. And question for Kim: why didn't we buy culture media way back in the 1980s? I mean, Hams F10, you could buy it off the shelf. Sigma had tissue culture media available to us. Why did we go to all the trouble of making our own media?
Maybe it was I was just stupid. All I remember is I would look in the Sigma catalog or in the Gibco catalog, and it was stuff we had to make. But I think I know what you're really probably getting at, Joe. And there was a lot of stuff we didn't trust. As embryologists, we are people that don't trust anything. We are people that want to see data. And we did not trust media that was pre-made, because we didn't know what water was used. We didn't know how accurate they were in making it. So we trusted our own hands. So we spent all that extra time to make it ourselves.
Yeah, so true. I actually remember a time when our pregnancy rates dipped a little bit, and Karin did a big investigation, and she figured out that the water that we bought, they had changed the glue that they used to put the labels onto the water bottles. And that glue had something in it that's managed to make its way into the water. And I don't know how Karin did this, but she figured out that was the source of our problem. And like I say, we just didn't trust stuff back then. Some stuff we had to trust, like the oil. We couldn't make our own oil, so we had to like say, go to the pharmacy and get it. Karin, any questions?
Well, even with the oil, as you said, Joe, we still had an incident where the fertilization went down, and that was due to the mineral oil. And you're absolutely right. The tracking down of the label and how that was stuck on, that was a real detective process, going to the company, who of course were very defensive and said they hadn't changed anything, and then just going through everything. That's how we found that out. And I mean, we had incidences where we had failed fertilizations, and we were done everything as normal, but at one point we were putting our some of our instruments into the hospital microclave to sterilize them, and we actually found out that they had been using formaldehyde on AIDS patients before they did our instruments. And it everything we had to watch. And as Kim said, in the end, you just didn't want to let anything go. So we wouldn't even we bought our own microclave rather than putting it in the hospital systems. And Kim, one thing you haven't talked about, and maybe because we were a little bit before you didn't do it. We used mouse embryos in the early days, and of course we did we did some of our quality control work on sperm in the way Jacques talked about, but we also used mouse embryos. Is that something that you ever used, or?
We used them, and I still think there's a lot of people that still use them. A lot of my laboratories still use mouse. They either use mouse IVF or they use growing of zygotes, mouse zygotes, for quality control. So I think it was used, and it still is used. Someone asked a question about osmolality, and I can't remember. The only thing I can think of how we would adjust osmolality, I remember I had a freezer depression osmometer, and after I'd measure it, we'd either have to add water to dilute it out. You usually didn't want to have to add something like sodium chloride to it. So you usually made sure you made it a little bit more, where the osmolality was a little high, and then you could adjust it by adding water.
A couple of questions for Corey from the chat. Corey, people are sort of interested in, you can answer one of these two questions. I'll give you an option. You can say, what are you doing, like research-wise, for the future at Cryos International? Or what are you doing to reduce your carbon footprint with all those shipments that you're doing?
Okay, I'll take the research question, because I can't tell you what we're doing about the carbon footprint. I know we do some things, but I don't have that kind of knowledge. So at Cryos, we do a lot. So we partner with a lot of media companies and others. We're actually doing a lot of egg research currently, a little less of the sperm research, but some of the things we're looking at, again, goes back to how do we freeze the best quality gamete? So that's the big thing that we're looking at, both in eggs and in sperm. We got the sperm that we have, so again, we can freeze it all and give you a vial that has a lot of dead sperm in it as well, but if we can freeze something better, I think that's where most of our research is right now, trying to find a better egg or better quality egg to freeze, as well as better quality sperm to freeze.
Could I ask one of the questions that's on here, which again, you've talked about some of the techniques, but this question is, what technique that has been discontinued would you like to see re-emerge? Pentoxyphylline, zona thinning, Z-score, or co-culture, of course, going back to the culture medium that we used to use, or anything, or has all this been left behind for a reason?
Who's that question for?
Jacques, sorry.
Yeah.
Jacques, can you hear? Do you want me to repeat it?
That's you, Jacques.
Well, in a perfect world, you would like to revisit techniques that came before us or that were 1980s. One question I see here is that what's your view on performing IVF in all male factor patients first with adequate motile sperm rather than going to ICSI? Yeah, that sounds reasonable, but it would require an IOB. It will require doing a real proper study, and we can do that nowadays. But I don't think you'll get the patients lined up to do this. They talk to each other. So that's an example of why wouldn't you do IVF, right? I mean, obviously we didn't know how to do this. Probably we could optimize the system for IVF in such a way now and go back to certain male factor infertilities with success. But whether you go from 40% to, let's say, 45% or 50% fertilization, I don't know. You would have to have a control group. So that's, I think, why we don't revisit. But more smaller details like pentoxifylline, I've heard that that's still in use. So I don't think that's gone, right? I see Kim saying yes. So, and also Corey nodding. So, and Joe. So there you go. So some things are done, but they're not necessarily, you don't get a, you don't capture an audience if you talk for 15 minutes about pentoxifylline. So you usually asked to talk about something much bolder and bigger and not a detail. And so that's why you don't hear about it. And that's, I think, why these papers are not submitted anymore. Reviewers would step on it here, but that's old news. And so, but a lot of these things are I still think exist. I don't know, Joe, if you have any that is being used and people think it has disappeared.
Yeah, I mean, we still keep some of those things in our toolbox. Pentoxifylline is always a last resort. You try everything you can before you go to use it. But if you're in the corner and nothing else has worked, then you have it in your back pocket ready to go. Calcium ionophore activation of eggs, same thing. Try to minimize the use of these agents. Don't want to be exposing sperm and eggs to things unnecessarily. But it's good to have all of those things, like say, in your toolbox, so that if you're in a bad situation with a patient, you have options and you have things that you can pull out to help those very rare patients that, for who nothing else works.
Hey, Joe.
Question for Kim.
Wait,
Ready,
I
Kim?
want to answer
Okay.
your question or comment on it. You talk about having things in our back pocket. We began making what were called test tube babies. And that's because we did all of our culture in test tube. I keep that in my back pocket. If there's a time when a hurricane comes to Miami, I can take my embryos, I can put them in a test tube, seal the lid after putting gas in it, and leave it in a 37-degree incubator for 5 days, and it will culture fine. Or I can put it in my back pocket and take it to the next lab. So that's one of the things that I think I learned in the early days in Bristol with Michael Hull's group, and I can still use today for an emergency.
Yeah, a question for Kimball. I see a lot of questions here from younger people asking about sequential media. Did we start with sequential media? We couldn't culture the blastocysts in those days, and then sequential came in as the answer to everything. Now we've developed, and we've got both types on the market. What's your feeling about where this story is going to go? Where are we going to land? We're going to carry on with the sequential? Are we going down the road only with single culture?
Well, I'm grateful for that question, because at least I don't have to talk about glucose toxicity. And I would say that I don't think there is a real answer. We're going to use whatever works the best. Whatever the data shows gives the best outcomes. And whether it may be sequential in some cases, and in some cases it may be non-sequential, or let the embryo decide. But I think we're going to do it based on data more than an idea. We like to put things in little categories, and we've put these types of media in different categories, but I don't think it's material to the discussion as much as what does the data say is best.
Your feeling, Jacques?
Yeah, I agree with all that, but of course, the single step media from the 1970s and 80s were very different from those developed by Culture Club and John Biggers and all the others. For $60 million, they developed a single step medium that I think is at least as equivalent as any sequential medium. I mean, that is obvious, but that you can't compare that to EBSS, for instance, which I worked with for years, or HDF even. So I think we're talking three phases: the old type simple media that came from cell tissue culture, then the sequential media that were developed for embryos, and then the K-SOM based media that were also developed for embryos. So I think single step has, embryologists want to make things easy. We wanted to make things complicated. I think that has changed because we didn't know, so we had to do things that were a little bit strange. But now it's about, well, simplification is important, and with single step media, you achieve that.
Thank you. I've got a question for Corey. There's several questions around protocols in freezing. So what do you think has been the biggest advance in sperm freezing? And can you tell us a little bit more about the freezing protocols that you use and how they've advanced?
Yeah, that's a great question. Again, like I said at the beginning of my talk, not a lot has changed with sperm freezing. I mean, it depends on where you're at. Some places are still freezing the same as they were 20 years ago. Just like we talked about, some people just put the cryoprotectant in, slowly lower it into the vapors and freeze it. I don't really know the answer to that question. I'm not sure I have a great answer for that question as to what's been the biggest change and something that's been relative. We use, there are the controlled rate freezers now that they're computer programmed. They have a good freezing curve. So that's what we currently use at Cryos. It controls the rate. Does it help? Does it make a better specimen? I'm not 100% sure on that. We've done some comparisons, and you could still find just as good specimens frozen in the vapor method. So does it help? I don't know, but it does standardize the project or the process. So I'm not sure I can answer the question as to what's the major thing that's changed that's increased sperm freezing, and I wish I could. As far as the protocol, again, that's not changed much either. We basically make two specimens, raw ICI specimens and IUI specimens, and they're pretty much made the same way we have been making them for all time. I mean, they haven't changed much. We separate the IUI specimens, take the seminal plasma out, and add cryoprotectant and freeze it. The raw specimens, the ICI specimens, we just add the cryoprotectant and freeze it. So there really hasn't been a lot of changes. And even in protocols, does my protocol work better than Kim's or anybody else's? Not necessarily. I mean, they're all pretty much the same. They don't give a lot of differences between the two. I think we're working towards that goal to find something that improves. I think vitrification may be the next level for us, but again, the volumes. We have to be able to freeze enough sperm and volume to make it worthwhile for people. The vitrification right now, if you're freezing a handful of sperm, that's great. And for male factor patients, that may be a great thing. For donors, it's maybe not. If we can get a big enough dose put together, most of the specimens that we produce come in 0.5 cc straws or vials, and the average dose is up to a cc. So I think vitrification is going to be that. I just don't think it's quite here yet in terms of ready for prime time.
Yeah, can I make a statement about that, Corey?
Please.
I think that you've nailed it, that it's very difficult to make those advances. And the reason it is because there's so much noise in trying to come up with a better method for freezing sperm, when your pregnancy rates for inseminations might be 15%. So how then do you find out something that's better than another thing if your difference is 15.1% versus 15.5%?
I agree with that, Kim, and I think that's something that we're seeing all across IVF now. I mean, with the success rates the way they are, what's significant now in terms of improvement? Is 1% significant? Is 0.5% pregnancy rate significant? That's a great question.
Corey, is there any prospect of getting some of these rules that you talked about, getting them changed? Like you talked about how sperm donors and blood donors are treated differently. You talked about how gay men are treated differently. Anybody working on getting those rules changed?
That too is a great question. What I find with the FDA in particular, they're not real open to talking about what they're doing in the future. So I go to a lot of meetings with the FDA people and have talked to a number of them. I do believe that they are going to change the entire tissue regulation directive. Right now the FDA looks at all tissues the same as every other tissue. Doesn't matter what it is. Semen's regulated the same as everything else. There are some other testing you have to do with semen, but everything's under one big umbrella. And I think that where they're heading now is to decentralize those tissues. So each tissue has its own guidance. So like when we talk about the fact that people from Scandinavia can't be a sperm donor for somebody in America, that's got to do with CJD or TSE. It doesn't affect sperm. It doesn't affect sperm or eggs. There's no effect on that. It affects dura mater and retinas are the two things that are affected by it, but the entire tissue industry is covered by it. So there's just things that are unfair. And I think that when they made the regulations in 2005, they didn't put that much thought into it. They just said, okay, we got to have some directive. We're going to put everybody under one umbrella. And I think over the past almost 20 years now, I think they've come to the realization that everything needs to be regulated a bit differently. There can be some standardization, but I think they need to regulate every tissue under a different umbrella. And I think it is coming, but again, it's the government and you're talking a major change. So, to rewrite that policy, they have to rewrite it, then do public comment, all this sort of stuff. So even if they do make a change, I think it's at least 5 years or more away. And I've been saying that for about 10 years now. Every year I've been saying it's been 5 years away and it's still 5 years away. So I don't know the answer to that, but I have hopes that the FDA is moving towards regulating tissues on an individual level and not blanketing everything.
Corey, one question. Do you have strict rules before a donor comes to give a sample? Do you give them a protocol for the 10, 15 days before to prepare, or?
We do not. We do a lot of prep with them. I mean, there's a long process before they come and provide a specimen for evaluation. The only thing we really require is we ask them to have 72 hours of abstinence before they provide. The problem with that is most donors are college age gentlemen, and 72 hours maybe
it's a long time
for some of those. So that's pretty much our only protocol. But to your point, again, we accept 3 to 5% of our donors, and a big part of that we reject is due to semen quality. We're not looking for an average ejaculate. We're looking for people who ejaculate better than average. To be a donor, you really have to have a higher concentration, higher motility, all of that, than you'd find in a normal or average ejaculate.
Okay. Karin?
I've got a very interesting question here from, well, in fact, Jacques, I'm sure you'll have a view as well, from Annabella Marcanetto, and that is, do you think that in all aspects, the laboratory and the techniques have improved, or do you think that anything has got worse? And what points do you consider key to continuing improving our results? So it sort of sums up the theme, really, of what we're all about here. So perhaps Kim first, and then maybe Jacques.
Okay. I can tell you right off the bat what I think has gotten worse, and that is the workload of the embryologists. And I see Jacques smiling. He knows how I am. And I have been an outspoken critic of physicians that dump on the labs, meaning there is no planning done for the workday. It's here's the cases, the lab is a black box, you handle them, bring back embryos to me. This has to change. There weren't major adjustments made when we started doing all the micromanipulations of ICSI and PGS, or PGTA as we call it today.
Yeah, I was laughing because you start with the negative first, which is fine. Things have improved a lot. Just in addition to what Kim just said, though, is that of all medical specialists combined, 50% of our time goes into looking at paperwork. It's looking at monitors and paperwork and stuff. And so I think, Karin, when Steve and Joe and Charles, when we were doing this in the 1980s, paperwork was there, but it was very minimal. It was really, really very minimal. So it's probably gone from what, 10%, 15% to 50% or more. I think in clinical embryology, the average for a clinician is 50%, for a nurse is 50%. For a clinical embryologist, it's probably more like 60 or 70%. And so I think that's part of the reason. Not just everybody needs PGTA or every MB needs a biopsy, which I hope will change soon. I think there are other reasons as well, including more follicular stimulation, of course. But those things have improved a lot. From all technological perspectives, things do. And I think part of that is the community of companies that are supplying us with everything we had to do ourselves in the 1980s. That's not just culture medium and microtools, it's everything else. We had to make our own pipettes, as Kim pointed out. And that is now standardized. The moment you start involving commerce, in spite of all the criticism that is out there, and some of it fair, you do get improvement of technology. You get improvement of products and quality control because they have to report to regulate. There are regulations for them. So you've taken all that away and given it to others. So I think that is an important improvement. But we are communicating much more now and much more effectively among each other. There's all these different things like this, webinars. There's of course social media. There are meetings that are specialized, like stress, but then there are also meetings that are general, and it's easier to attend, or it's easier to attend virtually, and that is making a big difference. So I think that the results are actually improving. And you know, when you look at the SAR data, and you just pick out implantation rate and look at the youngest age group, which you can compare. I mean, you can take out different etiologies, and you can look at groups that are comparable, particularly in maternal age. Then you see it goes up every year. Every year it goes up by, and we calculated it's just a little less than 1% implantation per year, from 1980 all the way to now. And so it does go up. It's just that because of its shifting age group, the average age has gone up and goes up a lot. When we were in the 1980s, it was just above 30 or a little bit below 30. Now it is getting close to 40. That's a huge shift. And that is, now that makes it look like the results haven't gone up that much, but you have to analyze the data per either age year, if you have that opportunity, or otherwise per group, as the HFEA does, as SART CDC do. So I think when you look at it that way, you see that results just go up every year. We're getting better and better, but it's not just technology. It's all the other aspects as well. Better training, right? There weren't any master program in the 1980s. The OBGYN, well, they were never trained, at least in the United States, they were never trained in IVF. Now they're trained in IVF. We were killing, we haven't discussed that today, but we were killing ourselves about what well-known medical people, when they touched a catheter or an equiretrieval needle, had to do ultrasound for the 10th or 20th time, how difficult that was and how the results varied, as they still do, but a lot less so than it did in the 1980s. And that is also because of training and training each other and openly speaking to each other about things like embryo transfer, which people at that time just didn't do. They just compared.
That's one of the key points that you have made, and I'd almost forgotten about that, Jacques. And that was when we first started, we couldn't talk to each other. Our medical directors would not let us talk to other clinics. It just wasn't allowed. And I can remember when we were having a period where fertilization rates had dropped, and we had actually just started to use commercial medium. We were still using our old medium, but we were bringing in the commercial medium. And there was one batch where, of course, I noticed straight away that the rates had dropped. And I was actually great friends with Karin, and I just thought, do you know what? I'm just going to pick up the phone and find out if somebody else is having the same problems. And lo and behold, it was the same cultural media from the same company. And she was very guarded at first, but they were also having problems. And then I did phone a couple of other people, but we were just not allowed to do that in our day. Everything was top secret because everybody was after the best pregnancy rates. You know, there was so much competitiveness. And the openness that embryologists have got nowadays, they just would never realize for 1 minute what it was actually like. And we almost had a gagging order in a way. It was very, very difficult to communicate with other clinics. And that's been a huge change, thank goodness.
Yeah, I agree.
Well, folks, I think, you know, we've been talking for a long time now, and I think it's finally time to wrap this session up. Maybe we're going to do a part 2 of this down the line at some point if Giles can take it. But I would like, first of all, to thank my co-hosts, Steve Davis, lifelong friend. Great seeing you, buddy, and thank you for being here today. Karin Dawson, my first mentor in life, and you know, someone who really started all of this for many of us, and whose shoulders we've been standing on for decades. Thank you very much for co-hosting today. I'd like to thank Kim Pomeroy. Thankfully, Kim, we don't have to make any media anymore, so you know, it's nice to get a glimpse of, you know, how hard that was and how difficult it was. Corey, thank you for being an industry partner, and thank you to Cryos International for sponsoring your talk today. And Jacques, of course, thank you to you too. You're always pushing the envelope. You're always there. The new innovations, the new ideas, you're always challenging us to do better. Thank you very much. And I'm going to hand it back to Karin now for a few words, and then it'll be on to Steve.
I'd just like to thank the organising committee for making this webinar available to, and just so that people can learn the difference between what it was then. But I'd like to particularly thank, of course, Jacques Cohen again, Peter Nagy, Marianne Savetes, Thomas Elliott, Fran Farley, Giles Palmer, and Violetta Sora. And I hope you've enjoyed this particular session. And we would like you to stay close with us and tell us what topics you'd like or want to have in the future. And just remember, we also have podcasts and webinars, which are all uploaded free to our website, www.ivfmeeting.com. And I've personally enjoyed this tremendously. Hope you have too. And I think, as Joe said, maybe this will lead to another session, because I think it's been fascinating to see the difference between when we started and what we have now. And it would be lovely to, you know, look at the future and how that may go. That perhaps that would be another fascinating session. But thank you, and I'll hand over to Steve now.
Okay, thanks to everyone. I really enjoyed this session. Really interesting, especially with Jacques. With Jacques, I think all of my career has been around for specific events, and it's changed on several occasions the route that we've taken and the investment we've made. He doesn't realize this, but he's been an instrumental part in my success in Greece. Thank you. Thanks to everyone. I'd like to introduce the next section. The next session of I3 is a webinar called Weird Science. This will be a gathering of esteemed experts from the world of animal and human reproductive sciences, with the aim to shed light on the captivating complexity and remarkable variety of animal physiology in relation to human-assisted reproduction. The distinguished speakers will share their most peculiar example of animal reproduction, highlighting the intricate interplay of physiological factors, astonishing reproductive strategies, and be challenged by you, the audience, and fellow presenters in a weird off event. I hope you enjoy it. Thanks for everyone. Bye-bye from me.
Bye from me as well.